So we have been speaking about number patterns, and we've sort of been discussing how to represent number patterns. On Monday's lesson, we spoke about finding a general formula for these patterns, and we're going to sort of talk about that again today, but we need to now relate that very specifically to the notation or the variables that we use when we do number patterns. Okay, so excuse me, we have been given a sequence here of -1, -2, -3, -4. Now remember, I always say to you, don't jump straight into the questions. First, look at your pattern that you have going on and establish or see what the pattern actually is. So how are you going from -1 to -2? Well, we're subtracting 1. If we go from -2 to -3, we subtract 1. -3 to -4, we subtract 1. So our pattern here, if we want to describe this whole thing in words, is that we are subtracting 1 each time. Again, we spoke about this on Monday. If you want to say you are adding -1, that is also absolutely fine. It means exactly the same thing, but you have described your pattern. So even if the question or the first question doesn't ask you to describe your pattern in words, start there. Know what your pattern is. Ooh, guys, sorry. Who knows why? Start with what your pattern is, and then you can start answering the questions. So if we go and sort of now look at our table, we have got 2 rows to this table. Our first row is the position of the term. So is it the first term, the second term, the third term, etc., etc., etc. And then we've been told we want the value of the term. Now, if you think about what that means, it's asking you what is the value of the first term. Well, if we look at our sequence, the first term is -1. The value of the second term is -2. And so we can fill in our sequence according to the pattern that we have. Now we can see, excuse me, we can see that our pattern only goes to -4, but our table also wants the 5th, 6th, and 7th terms. Now that's not a problem, because we know what our pattern is. We can now keep subtracting 1 in order to get our 5th term, our 6th term, and our 7th term. So we can follow our pattern or continue our pattern in order to get the rest of the terms. Right, I'm just going to stop because the chat is going and none of it is questions, none of it is focused. Guys, please, not only are you distracting each other, you are distracting yourself, you're distracting Yolanda and myself, because now we're checking the chat to see if there's questions coming through. Otherwise, we just disable the chat. Or I close my chat and I don't see your questions, and that's not fair, right? I need to be able to see questions. So please focus. We are using the chat now only to ask questions. That is the only thing I should be seeing on this chat right now. Okay, so we've got our sequence. We know what our pattern is. We have carried on adding our pattern. Now, most of the time, guys, we're going to ask you to find a general formula. So to do that, I'm just going to move over to this colorful looking block here, because we now need to be able to find a general formula in terms of what we call Tn. So if you look at question C over here, it says determine a formula for Tn. Now, we haven't seen Tn before. We don't really know what that is. And this is now the specific way that we deal with number patterns, or we write number patterns. It's in terms of Tn. But I'm going to explain what all of this means, and we're going to do this explanation, whoopsie daisies, in this little block so that we've got our notes outlined nicely for us. We know exactly what we're looking at, and hopefully it'll make sense. All right, so we know how to find a general rule. We've been doing that for quite a while now. That hopefully is not anything too new. So what we're going to do is we're going to start off by finding our general rule the way we usually do it. So if we just look for our general rule, we know that this is essentially taking our input values. Remember, our input values are these values at the top, which we have been using as X. And we want to somehow get our output values, which are the numbers at the bottom, which we have been using or representing with Y. Now, remember, I've told you that the first step is to multiply X by whatever you're adding or subtracting. So I'm going to say -1 times X. And then I'm going to check to see if I need to still add or subtract anything to that in order to get the outputs that I have. So if we consider the very first input, the very first input is 1. So if X is equal to 1, we want an output value, so a Y value of -1. So let's see what we get. If we take the rule that we've gotten and we substitute in place of X a 1, so Y equals -1 times 1, we get -1. That's what I wanted. And so that means this rule that I found is correct. Okay, so now that means I can substitute in any value for X and I will get my output. So for example, if I go back to my table and let's say I didn't know what the 7th term was, I could now take my rule, Y equals -1X, and I could substitute in X equals 7 because the 7 represents X. So Y is equal to -1 times 7. And -1 times 7 is -7. So we're able to get any output we want by using our rule. Alrighty, so if we now want to put this in the specific notation that we use for number patterns, your grade 8s, I'm about to stop and we're only 20 minutes in. I have just said to you that I am explaining what TN means. I said to you, I'm moving to the block and I'm explaining it to you. If you can't listen, if you can't do that, please rather just leave because you are making it so much harder for everyone else to concentrate. Now I've had to be distracted because you guys are not listening to what I'm saying to you. Right, if you have missed anything, you need to go and watch the video. I am not redoing an entire 20 minutes of this lesson because you weren't listening. So the videos will be up. You need to go and watch the recording. Simple as that. I'm not repeating myself. If you've chosen not to listen to me, that is now your problem. Second thing, someone asked, can we not say adding 1 instead of adding -1? We cannot add 1 because that is a positive value. If I said -1 plus 1, I would end up with 0. That I need to end up with a -2. So I need to essentially take away a -1. And subtracting 1 and adding -1 mean the same thing. But we cannot add a positive 1. All right. I really, grade 8s do not want to have to stop again and be angry. It doesn't do me any good. It doesn't do you any good. So please, let's focus. Otherwise, like I say, we just end this lesson and we move on. Right, so I'm explaining TN. So we know how to find a general rule. We know how to do that. We've done that. If you don't know how to do that, you need to go and watch Monday's lesson where we spoke about this basically for the whole lesson. So there's an entire sort of 40-minute video that explains and does these quite extensively. However, when we now start talking about number patterns specifically, we now start talking about, a general term or what we call T of N. Okay, so this is where the T of N comes from. T of N basically means exactly the same thing as the general rule. So it's asking you to find the rule for the number pattern. Now, who knows why mathematicians decided that number patterns, we need to use different variables and different notation, but someone decided that we needed to. Okay, so if we're looking for the general term, basically what we're looking for is our equation. So if we have a look and sort of break down further what Tn means, Tn is essentially the output value. It is your Y value. It is a general rule to describe the whole pattern. So you are able to, just like the general rule we've just found, you are able to find any number in your pattern. Whoops. All right. Now this TN notation is quite useful when it gets to number patterns, because if we now go back up to our table, this TN notation actually allows us to write down the value of the term as well as the position of the term quite easily. Right, so if, for example, you had something, if, for example, you had something that said T13, if we think about this, if TN is the general rule, T13 is saying to us, we are looking at the value of the 13th term in the sequence. So if we go back up to our pattern that we're looking at, and we go back to that 7, T7, the value of the 7th term, is equal to -7. So we are able to take our input and our output values, and we are able to write it in a notation using T and T of N. Right, now what you need to realize is that if you can write the general rule in terms of X and Y, you can write the general rule in terms of Tn and N, right? Whoops. Another thing I just want to point out, in case it isn't clear, is if you go back and have a look at what I've just written down, you can see that I have replaced N with 13. So N is giving me the position of the term. And that's why in the table, if we go and have a look here, we have got an N in the top row that represents the position of the term. It's the same as X. X is also the position of the term. It's the same variable, we're just now using an N. And so what that all means is if I want to write this rule, y equals -1x in terms of Tn, I have just told you, and I'm going to highlight now in case we're not listening, I've just told you that Tn means the same thing as y, and N means the same thing as x. So if you know what x is and you know what y is, you can now just replace them with Tn and N. So y is Tn, x is N, and I multiplied x by -1. So my general term in terms of Tn and N is Tn is equal to -1 N. It tells you exactly the same information. This equation in terms of y and x, and this equation that we have just written down in terms of T and N give us exactly the same information. We are just using Tn and N instead of x and y. So like I say, mathematicians for some reason decided that x and y was just not good enough when it came to number patterns. We want to use Tn and N. It does make sense because, as I've explained, this specific notation does allow us to say certain things. It allows us to write in shorthand, I suppose, the value of a specific term, as I showed you over here with term 7. So it allows us to write information in a shorthand or in a more concise way. Alrighty, so I'm just going to do that for a second. If anyone wants to take a screenshot of what I've written down so far, now's the time. Now is also the time if you would like to raise your hands to ask me a question. I'm obviously going to do more examples, guys. Please don't stress, this is not it. I'm just explaining what Tn means. But any questions, now's the time to raise your hands. Okay, there is a little reaction button to raise your hand. Tony, I did see your hand actually physically raised. So do you have a question? There should be a pop-up to unmute yourself.
Yes,
yeah.
Ma'am.
What's your question?
Me, ma'am. Oh, ma'am. Will this be in the June exam?
It depends if you have done number patterns yet at school. So some schools are different. Some schools have done patterns, some haven't. It will depend on your school.
Oh,
But if you
yes,
have
ma'am.
done it, then yes. Whatale?
So, ma'am, I wanted to ask if like TN and N is in like every number sequence, ma'am. Like in every
Sorry,
number.
say that again. You cut out. Is TN?
Is in like TN and N, ma'am, is it like in every like table, or ma'am, does
Yes.
it also come in differently? Thank you,
So
ma'am.
it's for every single pattern. We can use it for any pattern we work with. Yes. So it's like X and Y. Good. Letswe?
Hi, ma'am.
Hi. Okay, I can't hear you. I can't hear you. I cannot hear you. For some reason, your sound is very like crinkly.
Yeah, sorry, I muted her because I also felt it that there was some noise there. That's why we couldn't hear. Sorry,
So try
Riaba.
type your question out on the chat.
Yes, please.
Sibukazi?
Hi, ma'am. I wanted to ask that TN can be used instead of X, Y, or Y or X, like any constant.
So, well, Tn in relation to a number pattern means the same thing as Y. So Tn is the value of the term. So if we go here, Tn is the same thing as whatever the value of the term is. Whereas N, if we think about the variable N is then the position of the term.
Thank you, ma'am.
Okay. Gideon? No? Okay. Tando? Oh, no, sorry. There we go. Yeah.
Afternoon, miss.
Hi. Tando, just hang on 2 seconds. Yeah, Gideon?
So, TN most means general terminals. Now, why does it have to be TN instead of GT, miss?
Okay, I'm going to need you to repeat that. You cut out a bit. Let me just turn off my camera as well, just in case that helps. Okay, say it again for me.
So, TN basically means general term, right?
Yes.
Now, instead of it being GT, why did they put it in the abbreviations TN, miss?
I'm still not really understanding. So, what do you mean the abbreviations?
Must I'm gonna type it out quickly, miss.
Your guys, you can't see me because I've turned my camera off. Okay, no, Gideon, sorry. Try one more time. Let's see if I get this.
Okay, miss, because so basically general term abbreviated is TN, right, miss?
Okay, yeah.
Now instead of it being GT, miss, why did they put a TN?
Okay, I'm finally on the same page, right? GT would be if we just like acronymed, abbreviated, general and term. TN though is like the mathematical symbol or the mathematical language that we use specifically to number patterns. So it means the same thing, but again, for whatever reason, a mathematician decided to use T. It does sort of make sense because T, we're talking about term, and N, we're talking about number. So if we have term number 13, we are looking at the value of term 13. So the T and the N come from the values of terms and the number of terms. So that's where T and N come from. Does that answer your question?
Yes, miss. Thank you, miss.
Okay, I got there in the end. Thank you for being patient. Okay, I've unmuted you again because that's where I'm at today. Tandor?
Afternoon, ma'am.
Afternoon.
Ma'am, I was going to ask, ma'am, is this the only method that can be used?
In terms of TN.
Yes, ma'am.
So it's not the only method, but you will see as you go on in maths, it's the only method that we use. So
all right,
when you sort of get to grade 9 and then especially grade 10, 11, 12, if you plan on doing maths, we are only going to use TN. And so that's why we introduce it now so that you can be comfortable with it.
Yes, ma'am. Thank you.
Good.
Sorry, I just want to say that please ask also your questions on the chat. Like this, I can help teacher Sam and we can move faster. Okay,
Yeah.
because we cannot take every single hand. Okay, my people, so that we can move on.
Exactly. Okay, good, guys. So, don't know why I wanted to. No, sorry. I thought there was something on the chat. Okay, so last one, Khoitu.
Hi, ma'am.
Hi.
Ma'am, so I wanted to ask if we are ever doing ratio on numeric patterns, and it says that the ratio is -2. Do you -2 on the numbers on top?
Okay, say that again. Why are we talking about ratio?
Like if we're ever doing ratio on patterns, do we if we're doing ratio and the number says -2, do we do we use the numbers on top to get our answers on the bottom?
It depends, I suppose, what the pattern is. Okay, so if you're talking specifically about ratios, a pattern like 1, 3, 9, 27, this is a ratio pattern because what you're doing is you're timesing each term by 3, and so you keep going. You could also have a pattern like 1/3, 1/9, 1/27, etc., etc. And then what you're doing is you're timesing by 1/3 each time. It really depends on the pattern.
Okay, thank you, ma'am.
Okay. Right, but guys, just on that, in terms of ratio patterns or patterns where you multiply or divide something each time, you can work with them, but they won't be super complicated ones. All right. Laura, that TN plus C is fine. Yeah, I know some people use that. I personally don't, but it is fine. You can use that. All right, grade 8, I am moving on. Like Yolanda says, questions in the chat and we'll help you. Otherwise, wait until the next time we ask for questions. So we are doing more examples, so please don't stress. Let's have a look at this first number pattern. So I have said here, determine the general formula or the general term for the following. Okay, so second you're asked for general formula. Sometimes we call it general term or general formula. They really mean the same thing. I am wanting Tn is equal to something. I want my general rule. All right, let's not stress about that yet. Let's just look at our pattern and see what's happening. So if we go to this pattern, we've gone from 5 to -1. So I've subtracted 6. I've gone from -1 to -7. I've subtracted 6. I've gone from -7 to -13. I have subtracted 6. So what I see as my pattern is that I'm subtracting 6 each time. All right. So that therefore means that I can use this to go and find my general formula. Now, guys, if you want to start with y and x and then just substitute y for Tn and x for n, that's fine. I really don't mind. I'm going to start with T of n, but I'll show you what I mean if you don't understand what I'm saying. All right, so actually, no, let's start with y and x because that will make life easier. So if we've got y is equal to, remember I said to you, don't know why there's answers on the chat. I haven't asked a question yet. If we want the general rule, and I just do it in terms of y and x, I have said to you that the first thing we know we always do is we take whatever it is that we're adding or subtracting the same each time, and we times that by x. So we've got -6 times x. Now I want to double check if there's anything I should add or subtract to that to get my output. So if I remember, these are all our input values. So these are our x values. So if I take my first, yes, let's try that again. My input values are 1, 2, 3, 4. It's the term number that I'm looking for. So if I take x equals 1, I want an output, so I want a y value of +5. So far, the only bit of my rule that I have is that I need to say -6 times x. So -6 times x is -6 times 1, and that gives me -6. Now, I know that's not what I want. I want +5. That's what I said I wanted. So now we have to ask ourselves, what do I need to add or subtract to get from -6 to +5? So if we think of our number line, and I haven't drawn a very big number line, so we'll see how we go here. I'm going to have to add some more here. I'm starting at -6. I need to get to +5. So I am adding 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I need to add 11 to -6, and that will take me to the +5 that I want. So if I now go back to my rule, I know that I should add 11 to that to get my output. Now I can double check myself just to make sure that my rule is correct. If I go and do my check, and I now use x equals 2. Whoops, sorry. X equals 2, I want a y value of y equals -1. So let's use our rule. Y is equal to -6x plus 11. Substitute in your x value, -6 times 2 plus 11. And so we know that -6 times 2 is positive. Yo, guys. See, this is what happens when we don't focus. -6 times +2 is -12, and -12 plus 11 is -1. I got what I wanted, so this means that the rule that I found is correct. Right. Once we have found this in terms of x and y, it's very easy to go get it now in terms of t and n. So if I take this, remember we said y is the same as tn and n is the same as x. So now I just replace it. Tn is equal to -6n plus 11. I'm rewriting exactly the same rule, just with tn as y and n as x. Why? Because if I now do this, guys, again on the chat, we're distracted, and I've told you what's going to happen if we're distracted. I'm just going to stop. Because honestly, I've now spent time preparing this, time trying to make this make sense to you, and you just don't care. Right, I have told you Tn is the value of our term at a specific position, and N is the position of the term. So if I now wanted, say, for example, term 33, I'm giving you the position of the term, so I know that that's n, and I could go and substitute that into my formula. So Tn is equal to -6 times 33 plus 11, and I could get the value of my term at position 33, or whatever it is, whatever I ask you for. All right. So this is why Tn and n essentially mean the same thing as what we've been dealing with. It gives us the value of our term. So again, it's our y value, and the position of our term, which is, if we go back to the basics, the x value. All right. So as long as you can find a rule, you can always write it in terms of t and n. Right. So all of these people who weren't listening. Jeez. Right. I'm hoping we all understand where I got -6 from. I'm subtracting 6 in order to get each of my patterns. Zano, you cannot use the same for arithmetic and geometric and quadratic. They are different types of patterns. We have different rules. However, you've only start learning about different patterns from grade 10. So right now, we generally only deal with arithmetic or linear, or if none of you know what I'm talking about, these sorts of patterns where we add or subtract the same thing each time. All right. X in the equation, what it stands for, I've just explained that to you. X stands for the position, Y stands for the value of the term. If you don't remember that, you need to go back and have a look at the video. Are you supposed to be writing? Well, guys, these are your notes, so I would be writing if I was you. However, I am stopping now for anyone who wants to take a screenshot, so you could just wait to take the screenshot. In terms of examples, I'm still trying to get everyone to understand, so I'm still explaining. However, I'm hoping that I will be able to give you an example now, and you are going to give it a try. Right, I hope that everyone has taken a screenshot.
Yeah, just to add on that, guys. So the reason that we actually ask for you not to disturb while Teacher Sam is talking and not to ask the questions is because then whatever that you are asking, she might be actually explaining because she's not done explaining, right, my people? So please, 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 let's be patient. When she's done talking, then she can say, anyone who didn't understand, now is time for you to put your questions. Okay, so that she doesn't get distracted by a lot of questions on the chat. Okay, my people, and we haven't given you any example for you to try by yourself because we realize that many people still don't understand, and she has to explain the activities that you were supposed to do by yourself. Okay, we got this, my people.
Guys, just on that, like Elaine has just said, half of those questions that I've just answered, I had already explained. And so what that means is that you're so focused on asking the question, you're not listening. If you just listen, 9 times out of 10, I've probably answered your question already. And then if I haven't answered your question, please make sure you put it on the chat so I can help you. But like I say, half of those questions, I had now had to explain for a second time because we just weren't listening. And I mean, I hope you don't do this at school. I hope that you sit and you listen and you make sure you understand and then you ask your questions rather than just rushing into it and then not listening to what's going on. All right, so I want you to try and find the general form in terms of Tn for this next pattern over here. So it's the same instruction, exactly the same, but now you are working with the patterns 0, 3, 6, and 9. If you have no idea where to start, my hint to you is just start by looking at what the pattern is. What are you adding? What are you subtracting each time? I'm going to leave question A's solution. So I'm going to leave this all here for you. So you can try and follow what we did to try and get your rule. Now remember, the rule I want is in the form Tn. So your answer should be Tn equals and then your rule. Right, so give it a try. Remember, answers on the chat. And then after a few minutes, I will ask you for your answers. Remember, grade 8s, I'm not asking you to describe the pattern. I want the rule. So yes, we're adding 3, but now you need to take that and put it into this rule format. Put it into Tn equals. And remember, grade 8s, if you're struggling, write your rule as y and x, and then you just replace the t and the n if you're really struggling with that, okay? But rule. Okay, it seems like we're on the right track. We're getting there. Good. I'm glad you're trying.
Let's go, my people. Let's go. Okay. So guys, you see now that the way that you have put your answers on the charts, right? You have also put your answers on your book, because definitely we're getting different kinds of answers. And I hope that we are not panicking, because then teacher Sam will correct us, okay? So you must be able to correct what you have written. Okay, guys? And y'all are doing really well, so thank you.
Guys, I just also want to remind you that the question did not ask what are the next 3, 5, 7 terms. The question asked for the general rule. So it's great that you can tell me what the next couple terms are, but that's not what the question asks. So make sure that you're answering the question. I'm going to give like 30 seconds or so, and then we're going to have a look at the answer.
Yalla, awesome, my people. And remember, hint, hint, definitely in your exam, you'll have some questions like this, okay? You might have one question like this, but definitely it will be there. So it's a good thing for you to know it, okay? You're doing really, really well. Keep trying, guys. Keep trying. And feel free to go and rewatch it, okay? Because once you miss one thing, then the rest of the people are leaving you with the bus. So if you see that you were not coping in today's class, okay, you still have this lesson, and you can rewatch it tomorrow, rewatch it, reinforce it in your brain, and definitely you get it. Okay, that's it.
All right, guys, let's have a look. So I want to say like 50% of us got it. The other 50%, we're there. We're halfway there. We just need to do the next little bit. All right, so if we have a look at our pattern, so all of you beautifully could tell me that this pattern, we could very clearly see that from 0 to 3, I needed to add 3, and that pattern continued. 3 plus 3 is 6, 6 plus 3 is 9. And so it's very clear that the pattern that I'm working with, I'm adding 3. Okay, now remember I said to you, when you now want to find your general term, so remember we want Tn. When we want our general term, we take the thing that we are adding or subtracting each time, and we times it by n. So this is going to be 3n. But I need to double check that I don't need to still add or subtract something. So this is where our check comes in. So if we do a quick check for ourselves, and remember your input values are 1, 2, 3, 4. It is the position of your term, that is n. If we now say n equals 1, so we take our formula and we substitute in place of n 1, we know that we want an output value of 0. So this would be 3 times 1, and that gives me 3. However, remember, I've just said I don't want 3. I want a y value, or I want a tn value of 0. So now my question is, how do I go from 3? Doesn't want me to write an I. Or go. Okay, cool. So how do I get from positive 3 to 0? Well, hopefully we don't need to draw a number line. Hopefully we know that what I need to do is I need to subtract 3, because 3 minus 3 is 0. And so that's telling me that's what I need to add to my rule. Now, again, we need to double check ourselves. We always want to double check that what we are doing is correct. So now I go and take my n value of 2. So if n is equal to 2, I'm going to substitute it into this formula and double check that I get a tn value of 3. I don't know why my pen is choosing to be difficult. Right, so tn is equal to 3n minus 3. Let's double check that we get what we want. N, I've just told you is 2 because that's the input value. So 3 times 2 minus 3. 3 times 2 is 6 minus 3. And we know that 6 minus 3 is 3. Look at that. That was the tn value that I wanted. I got what I wanted. And so what that means is that this rule is correct. Right, so a lot of you had said tn plus 3. Again, really close. You're on the right track. Yes, our rule, if we wanted to describe it in words, is that we are adding 3 each time. Absolutely. But that's not the rule. The rule needs to be, I don't understand. Our rule then needs to take that plus 3 and translate it into an algebraic rule that we can use. Right, so take your screenshots. Anyone with questions, you've got 2 minutes. You can raise your hand. And then, yeah. Sibukazi, algebra is not our next section, the section after. Lixa?
Hi, ma'am.
Hi.
Could I please get the Monday poll because I was not there.
You can get it online on Watobe's website.
Okay, ma'am, thank you.
Watobe.com. Dlamini?
Hi, ma'am.
Hi.
I just wanted to ask if when is the video gonna be uploaded?
Yes, the videos get uploaded within 24 hours. So Monday's lesson is already on the website, like I said, and this one will be up by tomorrow.
Okay, thanks.
Nice, my people. Y'all did really well.
Right, Sibukazi, last one. Guys, you'll also see that the quiz link will be on the chat for you. There you go. Yolanda sent it. Make sure you get it. Sibukazi, sorry.
Oh, ma'am, I was asking, is it necessary to use the Watobe app or do you need to use the Zoom app?
I want to say no, Yolanda. They don't have to have the app, hey?
Do you mean to do the quiz?
Yes, ma'am. Or to join the call.
So, okay, so Sipokazi, I'm not sure if you have signed with Watobe, because if it's like your trial, you still have access until they stop your access. Then you need to sign in with Watobe. Because if you are new, then I guess now today's just your trial lesson. Okay, so you should be able to click on that quiz that I've sent down there, and then you can just try it your best. So I'm just not sure. I'll find out for you. I'm just not sure if you can access all the videos of Watobe because it's still your trial and you haven't signed in yet. So you might not be able to access everything. Okay.
Yes, ma'am.
All right, guys, your quiz link is there. Also, just because the question has come up, please also remember that every course that we've done, all of those videos are online. So courses that we did right at the beginning of term 1, they're there.